Hello Willow class, welcome to our first YouTube video, all linked to the learning letter that I've sent out on the 30th of March. It's so great to be able to post some letters to you, and I really hope that you're all doing well. I hope everyone's feeling well, and I hope you're getting an opportunity to have a bit of sunshine. But I'm going to talk to you a little bit today about the first learning letter that I've sent out, and Mr. White and I have set for you as the first learning day is some maths, all about fractions, and of course we visited fractions a few times this year, so this is a recap of some of the skills that we're going to be learning. In this video, I've got a little tutorial for task A and task B, which are two different types of fraction skill we're going to work on. And then you can have a go at doing task C if you'd like to, which is some problem solving. Please go as far as you'd like within the task, but do dip into each of them and have a little go. Remember, if something's being challenging or you're not sure, just move on, absolutely fine. I've also created some answer sheets for you, and the same rules apply in class. 3 and mark them. Say it for me. 3 and mark them, and then it helps you know if you're on the right track. So first of all, let's talk about task A. Task A is all about finding fractions of numbers, and the rule that we often talk about is we divide by the bottom and we times by the top. Should we say it together? We divide by the bottom and we times by the top. So if I had a fraction, for example, 1/4, then I would divide by the denominator and times by the numerator. The same here, when I've got 3/4, I divide by the denominator, I times by the numerator. But the difference is if the numerator is 1, which we call a unitary fraction, then actually you don't need to worry about timesing by the top, because if you times anything by 1, the answer stays the same. So when you have a fraction that looks like this, then you just divide by the bottom. When you have a fraction that has a number bigger than 1 on the top, then you need to divide by the bottom and you times by the top. So let me show you one. So I have got a number sentence, and I'm going to do 1/4 of 28. 1/4 of 28. Remember my rule, I just need to divide by the bottom. So I need to do 28 divided by 4. Now, we can use our mental maths to do that, or of course, if you feel more comfortable, you can do your counting up. But a really good tip is to try and start from 5, because we're going to be going a bit higher into the times table. I know that 5 times 4 is 20, so I know already we've got to that point. 24, 28, it goes in 7 times. So 1/4 of 28 is 7. Get it? Got it. Right, okay, let's try the next one. So we're still on task A, and this is when we're talking about those non-unitary fractions. This is when we're talking about the ones when you have got a numerator that is bigger than 1. So I'm going to go with 3/4. So if I had 3/4 of 28 again. So my first step is I divide by the bottom. 28 divided by 4, which just worked out, is 7. That's my step 1. And I make a jotting. Step 2, I then times the answer by the top. So I'm then going to do 7 times 3, because I've worked out what 1/4 is, but I want to know what 3/4 is. 7 times 3, 7, 14, 21. So 3/4 of 28 is 21. You also kind of have to have a bit of a think. Does that make sense? Because 3/4 is nearly a whole of the number. It's a lot of that number. And is 21 most of 28? It is, isn't it? So that will help you with task A. Let's talk about task B. Feel free, if you want there as well, to pause the video if you want to have a go at doing task A and then come back to task B. So task B is all about adding, subtracting and multiplying fractions. Okay, so when we're adding and subtracting fractions, to start off with, it's just to remember that the denominator stays the same, or we want to make the denominator the same. So for adding and subtracting fractions, if I had a sentence, for example, that was 2 8s add 4 8s, looks like that. The denominator, the bottom number, it stays the same. So actually, it's quite an easy one. We go 2 8s of 4 8s. My answer has to be an 8s because the denominator stays the same. And I just do 2 add 4. The answer is 6 8s. Try another one. Let's do subtraction. Same rules apply. If I've got 7 eighths and I'm taking away 2 eighths, the answer has got to be in eighths because the denominator doesn't change. So it's going to end up as a 7 take away 2, which is 5 eighths. Okay, so that's the first part. Sometimes our denominators in our problems are not the same, which is where we then need to work using what we call a common denominator to help us. And we've worked on this together, and I know you're going to be great at this. So if I have, for example, 7 eighths, and I want to add it on to 4 sixteenths, you'll see there that my denominators are not the same. So my job is to transform one of them so that they are the same. So I can choose, I can turn this one into eighths, I could change this one into sixteenths. You choose. I'm going to turn this one into eighths. So I'm going to draw my little arrow underneath and transform it into eighths. I've got to think, what did I do to the 16 to turn it into eighths? I halved it, I divided it by 2. And you all know my special rule that when we find a common denominator, when we try and change the denominator, then we do to the bottom, we do to the top. What we do to the bottom, we do to the top, and it always is the same. So if I've divided 16 by 2 to get 8, I'm going to do the same with my 4. I'm going to divide it by 2. Which then gives me a much easier number sentence. 7 eighths add 2 eighths. 7 eighths add 2 eighths gets me to 9 eighths. Okay? Sometimes then it's not as simple as that. It's not a case of just doubling one of them or halving one of them. Sometimes we're in a situation that we need to think deeply because we have to find a common denominator that isn't as simple as that. So if I have a quick look at one of the problems up on my screen. If you had, for example, 2 fifths, I'm just going to adapt it really quickly, add 2 15ths. You have to think a bit differently about this problem. So I want fifths to turn into 15ths, or 15ths to turn into fifths, but I've got to be careful because I've only got 2 on the top here, so I'm going to try this one. If I want to transform my fifths into 15ths, think carefully. What have I done to 5 to turn it into 15? 9, 10, 15. I've multiplied it by 3. And if I've multiplied the bottom by 3, I've got to multiply the top by 3. So 2 times 3, that's 6. And I'm in a really great position again, because now my number sentence reads like this. 6 15ths and 2 15ths. 8 15ths. Well done, you're doing a really great job. So the very last thing I'm going to explain is multiplying fractions. Now this is a year 5 skill, so year 5s, stay online, listen to it really carefully. Year 4s, you are welcome to listen, you're welcome to hear it, but really important, this is a year 5 skill, okay? So if I'm going to go on here and I'm multiplying fractions, when we multiply fractions, they appear in 2 different ways. Sometimes you have it where a fraction is multiplied by a fraction. So it could look like this. 5 6 times 3 quarters. Okay? It's really simple. Work your way across and multiply across. I would start with the numerator. 5 times 3. Let's go along. 5 times 3. 5, 10, 15. Put 15 on the top. You see I just followed the number sentence. Then I've got my bottom part, my denominators, and I do exactly the same thing. I'm just going to follow the number sentence. 6 multiplied by 4. So I do 6, 12, 18, 24. So 5 6 times 3 quarters, 15 24ths. All you do, multiply across, all the way along, follow the number sentence, no changes, okay? Sometimes we have it that our number sentence is actually going to be multiplied by a whole number. So we've got 5 6 and it's being multiplied by the whole number 3. Now the great thing about this is it's the same as saying 5 6 add 5 6. add 5, 6. Because I'm just saying, I want 3, 5, 6. Now we just follow the same rules as we did before. When we're adding fractions, we don't change the denominator. So 5, 6, add 5, 6, add 5, 6 is 15, 6. 5, 6 times 3 is 15, 6. Okay? So repeated addition is a great way of going around that, just thinking what that number sentence really means. They're saying they want 3 lots of 5, 6. That's the same as saying 5, 6, add 5, 6, add 5, 6. Now, if you're feeling like you really want to challenge yourself, think about the answer. So 15, 6. At the moment, that's what we call an improper fraction because it's top heavy. The numerator is bigger than the denominator, which suggests this is more than 1, more than a whole. So if I'm thinking in 6, a whole 6 would be 6, 6. 2 would be 12, 6. So I know I've got at least 2 whole ones. And then because I've got 15, I've got 3, 6 left. So my answer would be 2 and 3, 6, or 2.5. That level, you don't have to convert it. Your answer would be absolutely fine if you want to leave it as 15, 6. Willow class, you're all absolute stars. Remember, pause this video as you go. Maybe try task A, try task B. Choose whether you want to try task C. Challenge yourself, but also stop where you think you need to. Okay? We're missing you all. Take care. Bye.